So now to answer part A of the question. Part A was dealing with intervals of increase, decrease. For this function over this interval. So using our sign chart, and actually this is a mistake here. I put these arrows on here. That's not really accurate because we're only going from negative pi to pi. So let me erase those arrows. That's not really true. And maybe just put some parentheses here. That'd be a little bit better. So negative pi on the end and pi on the end here. And then within here we have negative pi on 2, and pi on 2 is the critical values. Okay? So negative pi on 2, it is symmetric, but again, it doesn't really matter so much for these little sign charts. So negative pi on 2 and pi on 2. And we just want to know the value, or I should say the sign of f prime along these 1, 2, 3 subintervals. So going back to f prime, it's hard to see here, we have cos x 1 plus 3 sine squared. But we know, as we just explained, that the 1 plus 3 sine squared, right, that expression is always positive. So the only thing right now impacting the sign, SIGN, of the derivative, the only thing impacting it is the cos function. Right? This factor will not impact the SIGN of the derivative whatsoever. Okay? So if we take a test case, I'm going to take 0 firstly here. If I take 0, between negative pi on 2 and pi on 2 for this middle interval, and I plug 0 into the cos function, I'm going to get a positive 1. The important thing is that it's positive. So I have positive times a positive is positive. Therefore, the first derivative is positive here. And we now know that the original function is going to be increasing on this interval. Okay? And now we take test cases over here and over here. So cos between negative pi and negative pi on 2, you can really just think about quadrancy here, right? You don't have to take a test case per se and start picking particular values. Just think about the cost function for a second. I'll use this picture back here again. Between negative pi and negative pi on 2, we are in the third quadrant, and we know that cos is negative in the third quadrant. So that determines already, without picking a particular value, that cos x up here will be negative when I'm considering this subinterval here. And therefore, a negative times a positive will be negative, and therefore the derivative is negative, and therefore the original function is decreasing on that interval. Same argument for pi on 2 to pi. We'd be in the second quadrant from pi on 2 to pi, and therefore cos will be negative there again, because we know cos is positive in the first and fourth, thanks to all students take calculus A and C here. So cos is positive in the first and fourth, therefore by implication it's negative in second and third. Therefore cos is negative here, and it was the only determiner of what the sign of the derivative would be, so therefore we have f prime is negative also. And that means the original function is decreasing. So now we know everything we need to know to answer parts A and really part B as well. So let's just answer them all at the same time here. We have a local minimum where? Well, the function was going down and then it went back up. So therefore there must be a local minimum at negative pi on 2. So negative pi on 2 comma something. Right? And there's a local maximum at pi on 2 because the function was going up according to this and then went down after that location. So there's a local max at pi on 2 comma something. All right, we'll figure out the somethings in one moment. So now the intervals of increase and decrease are obvious from the picture here. So increasing on what? Negative pi on 2 to pi on 2, not inclusive of the endpoints in all these problems, and decreasing on everything else. Negative pi to pi on 2, sorry, negative pi to negative pi on 2, and pi on 2 to pi. All right, so we just need to figure out the values here. We just plug them back into the original function, which was sine x plus sine cubed. Okay, So sine x plus sine cubed. So f of negative pi on 2 will be sine pi on 2 plus, sorry, sine negative pi on 2. I was already thinking of the other one. Sine negative pi on 2 sine negative pi on 2 cubed. Okay. You can take the negatives out of all these, right? So it'll be negative, because the sine function is an odd function. It makes it easier to deal with a little bit. I don't have to think about negatives inside here. The cubic function is also an odd function, so the negative comes out of the sine and also comes out of the cube. So make it a little bit easier. Sine cubed of pi on 2. All right, sine of pi on 2 is what? 1, right? Sine of pi on 2 is 1. So this does nothing other than negative 1 minus 1 cubed, which is also 1 back again. So negative 1 minus 1 is negative 2. So negative 2, that's our local min value. Now, without doing this whole process again, it should be pretty clear that if you put pi on 2 in here, right, it's going to be the exact opposite sign of this one. Again, because sine is an odd function, so therefore we should have a positive 2 here. And there's our answer.